May the 12th, 2024. Guys, before I get into this video, let me say Happy Mother's Day to every mother on this planet, everywhere in every corner, because you deserve it. You are the hardest working member of the family. I don't care what anybody else says, and you have to put up with more than anybody. So happy Mother's Day. Relax. Enjoy yourself. Enjoy your friends and family, or just kick back and enjoy the time off. But happy Mother's Day. Now, what we're looking at are the last 3 days of solar wind speed in the purple. And this is where we started seeing higher elevation. Goes in through yesterday, and now we're in today. And today we're seeing some of the highest speeds so far. And you're talking about 990, 994. I think I saw a 996 in here earlier. Anyway, 990, we'll say, well over 2 million miles per hour. Very fast, a lot of pressure. Let me also point out that the density, which is right here, that's how thick that proton cloud is, that cloud of energy that's around the planet. It is thinner. It is down to really, let's see here, below 1. Why would that be? I've talked to you about it a lot. The faster this wind speed is coming in, the thinner the smoke is. In other words, you got a campfire, smoke's coming up, very thick smoke. The wind picks up. The smoke appears to be very thin at that point because it's getting blown away, thinned out. And that's what we're seeing with the plasma density here. And you're hearing a couple of my huskies in the background right there. I'm not going to fool with them. It's Sunday. They're a mess, I guarantee you that, and they're a handful. Anyway, we've got, again, 900 plus mile per hour solar wind speeds, and the temperature, guys, is very, very hot. That's concerning to me because the Earth is heating up, and we're coming into hurricane season. We've talked about that before. Now, I was looking at the USGS, our earthquake monitors, and we haven't had a lot of quakes as far as strong ones. The strongest one is today, and it is 17 kilometers west-southwest of Brisas Bar de Suchiate, Mexico. Here, this is Guatemala right there. Let's pull this up. I think it was just offshore, and it's next to this fault line. That fault line, guys, is infamous because it leads into the San Andreas Fault. Anyway, 6.4. It was very deep, 75.4 kilometers. A lot of times you'll see them shallow, but this one was deeper. I did not see a tsunami warning on it, but we're close to this plate. And as we see the energy from the sun absorbed through the magnetic shields, just like I was showing you with the ground current illustration when CERN got knocked out, that energy builds. Now, sometimes you can have a quake just from the pressure of a solar wind speed increasing that much, or it could be magma movement in the planet. In other words, magma moves, it shifts everything. There's crustal displacement. May be very small. It may be something you can see from space like the San Andreas, but a lot of it can be underground. And when we're seeing these along these fault lines, that's what it makes me think of. Either pressure on the plates from the solar wind or magma movement underground. And we're seeing that just across this along the mid-Atlantic ridge up into Iceland, guys. Look at this right there. No big quakes now, but the volcanoes are there. What I'm saying is this is an outlet. This island goes very deep because it is a outlet for magma. It's a magma chute or tunnel or tube, anything you want to call it. And as the Earth heats up, these tubes will allow that lava that's being heated deep in the Earth to climb up hundreds of kilometers. And then you start seeing it pour out into the volcanoes. The Earth is being heated internally, is my point. Now, if we back this out, guys, you can see, as usual, that the Ring of Fire has the most activity around the planet. And there was a lot of pressure during that time, especially today. You see that 6.4? That's because of this 900 plus kilometer solar wind speed. Again, either moving the plates from pressure or causing internal movement of our magma fields. And there's many, many of them out there. Let's take a quick look at spaceweather.com. Very good site, guys. Current solar wind speed, 885, just under 2 million miles per hour. The density is very low. See that 0.58, less than 1. That's because that wind is so high and there's not a lot of CMEs involved in it right now, but that's about to change. Let me pull this up. I'll show you what I'm talking about. It says the storm is over, but this weekend's extreme geomagnetic storm is over, but there may be a last gasp. NOAA forecasters are currently predicting a return to severe G4 conditions today on May the 12th, when one or more CMEs may hit Earth's magnetic field. Of particular interest is the CME from yesterday's X5.8 class flare, a potent storm cloud that could spark renewed auroras if its internal magnetic field is oriented correctly. And we watched the magnetic field split during this event and head south, and it opened up our magnetosphere and let a lot of energy in. Now, that report came out before we just had this another X flare, X 1.0 right there. See it? We've been having strong flares today, but that's the strongest one. So definitely it will continue past the weekend. Usually you're looking at a couple of days, 48 hours for impact from the time it leaves the surface of our sun. And so you add these up and possibly could be going into the 14th. But we're still at a 75% chance of X flares. The good thing about it is that huge sunspot we've been dealing with, 3664, is turning to the right, about to get to where it's not as dangerous to us on Earth because it won't be directly facing it. But in the past 48 hours, X58 and M31, X15, M8, M3, M2, and then just recently, you can tell because this is pretty much live, an X 1.0. Now, there's something else we need to pay attention to. In the video yesterday, I think it was, I showed that we had a backside flare on the left side of this image. Very strong. It looks stronger than the ones we've been dealing with, and that's turning around towards us now. It is in the northern hemisphere of the sun, reaching down, or this area is to its equator, so it definitely will be Earth-facing. But notice around the edges of the sun, you have a lot of light, and you have some dark places here. This is the sunspot that we've been dealing with all the X flares. You can see it's light there. But notice from right here all the way down to about here, it's very light. That is where that big solar flare came from on the back side. And look at these magnificent magnetic loops. Guys, you could put 100 Earths inside that circle of this magnetic loop very easily. And you see these magnetic canopies all the time, but when you start to get around these sunspots, they start expanding. And the canopy is what traps a lot of energy onto the sun. In other words, as it's emitted, these loops it'll rise, loops will pull it back down. But when you have a CME that just is such a rapid explosion from the surface, it does not have time to come back down. It's moving at such a high velocity and power that it's expelled into space, and in this case, towards us. Now, this is a composition of 3 different cameras. Notice that? And up until about a year ago, we could get these in motion like the rest of these Solar Dynamics Observatory images. But this one no longer does that. It doesn't matter. It tells us exactly what we need to know with 3 different cameras. What am I saying? See these brown areas? These are large sections of the sun that are like ropes. And they can energy travels through them. We're going to watch a video here in a minute, and you will see what I'm talking about. Energy's transformed through these, and they can actually explode. One end can leave the surface of the sun in a whip-like motion and strike the surface of the planet. We've seen it too many times, causing earthquakes, because there's a tremendous amount of energy in there. In the blue area, these are coronal openings. That's where the solar wind escapes. Why? Because there's no canopy. Like we're saying here, capturing the energy leaving the sun, solar wind, everything else, looping back to the surface, feeding back on itself. But in these openings, there's no canopy. It's like a clear sky on the planet Earth, no clouds. And that energy goes straight into space. And when we're dealing with that, as far as Earth facing, our solar wind picks up. And people start to feel that. You get increased solar wind and you're sensitive to it, you can tell it's there. But again, a magnificent image of the creation of our Father in heaven. Now, another combination of 3 different cameras. What you got, I think, is 12 cameras on the SDO. Each one has a different filter. to bring out certain aspects of what you're looking at. Here is the sunspot we've been dealing with, and here's what's coming around the corner. See that? Right there. And this is after that explosion we saw. I think I did capture that yesterday, and I'll put it into this video. Now, this is an SDO image, and this is really the clearest one as far as unfiltered that we have. It's filtered somewhat just so that you can look at it, but no coloration to bring out the other characteristics. Let's play this through. Notice I've got it set to start yesterday. Let's go through. Here's the sun flare we've been dealing with, and here's what's coming. We got a section here. I'm not sure how hot this will be, but this section is where we saw that massive explosion, and it seems to be quite active. Watch it. Also going to see the last solar flare. Notice this. This is called a prominence, guys. It actually expands beyond the view of the camera. Look at that. And I think on stereo B or A1 that you could see it reach much further down into space. But this is what we're going to be dealing with. Now, this sunspot could rotate all the way around the sun and come back, and all that will change would be possibly the size, but the number. It will no longer be the 3664. So, and we've seen that many times now. It takes about 27.5 days or something for a full rotation. Say from right here, if this thing would rotate all the way around next month to be in the same position. So we would have a couple of weeks of dealing with it. But what we need to watch for now, I think this one's getting far enough to where we won't get a direct blast unless it's a major X-flare, which there is a 75% chance because as they get this way, the energy, or they get to this side of the sun, the energy of a blast would blow that way. Like I said, from a surface of a circle or a globe or a basketball, whatever side it's on, that's the direction of the blast. Except when you have a very powerful X-flare, it radiates in many directions, and if you can see the light, you're going to get hit with a photon, not proton, but a photon burst in 8.2 minutes that has just traveled 93 million miles. That's how powerful this creation of our Father in heaven is, how perfectly balanced it is to keep us warm enough to have an atmosphere and survive. It's amazing, isn't it? And of course, we're not the only planet out there, but we're the one that we're concerned. This is the one we have to be concerned with now. Now, let's take a look at another camera on the same satellite. This is called the Magnetogram, and this is actually the colorized one. And that gives you the colors of different magnetic charges here. In other words, you get a red and blue in this area. One's a positive, one's a negative. They're going to arc over. Eventually, you see all those magnetic canopies stretching. You saw the filaments stretching across these areas. It's like laying a wire across your battery post. There's going to be a spark. This one actually had 3 different magnetic configurations. Here's what we got coming around this side. You can't really tell yet, but we definitely see the blue in one side charge here. This is the area that I'm concerned about. We're not getting a good look at it now. Now, this sunspot right here is not very large, but it does have a growing positive and negative charge. Good thing it's in the northern hemisphere. Now, even though the system coming from around this edge, we don't really see it good yet, is going to be in the upper atmosphere. The upper hemisphere, northern hemisphere of the sun. Something that strong, it doesn't matter. If you're facing it, high or low, you're going to feel it. But what will happen, and a lot of times the most concentrated part of that proton wave, we call plasma density, may go above the Earth or below it, just depending on the angle. Usually, if it's in the northern hemisphere, the main part will go above us. But when you have a halo, that's an explosion that you see it from all sides of the sun coming at the planet, like we've been seeing for the last, 2 weeks, then that's out a window too. You're going to have the effects of it. Let's play this through. We'll watch what's coming. We're seeing that blue spot emerge right there. They're starting to grow the opposite charge here. This is the one I'm interested in. I just wanted to do this with you guys live so we can see. This is coming. This timestamp is current. The last frame is the last one today before it starts back. Again, this is area interest. It's kind of hard to see right now, but what I do want to do is show you the explosions from 2 different satellites from yesterday, and that's my concern about the area here. Let's take a look from SOHO, a different satellite, of the top left of this, and that's what I'm concerned about. Notice how much stronger the energy that's emanating from this side is from the side of one of the largest sunspots we've seen in a long time. Check that out. These are energized particles. Normally you wouldn't see them like that, but you've got protons involved and photons. Protons get to the Earth in a couple of days. Photons again in 8.2 minutes. The same as the plasma tubes that connect the Earth and the Sun, called the Earth-Sun connection. That's how fast they transmit energy from the Earth to the Sun. From the Sun to the Earth, almost like an umbilical cord. But the satellites pick that pulse up also. Now here we're dealing with the flares coming off the right side. I've just got it going slow. Another flare from the bottom, very strong. Not as strong as this one, but it reminds me. And just keep an eye on what's happening here. Here's another one from that flare today. This side is heating back up. Let it play through at full speed. Keep an eye on this. You don't see the energized particles in the specs yet. Once that large flare goes, everything lights up. And there's that X, there's the other one. Look at the energized particles. These satellites, guys, they take a beating. Some of the images you see from stereo A or B, those satellites are past their expected life point, and their imaging has been battered over years and years of this type of abuse, basically. Same satellite, much wider view. One camera's close, the blue camera's not. You've got Mercury, I believe, and Mercury and Jupiter here. Same images, look, coming off of that sunspot. Goes back to the 8th, when all this began. Let's just let it play through. It's amazing. This is the one you really get to see the comets that come in and hit the sun. There's a lot more than you think. There's our energized particles. Look at the size of that. Again, the sun is the size of that white circle. It would take 119 of our planets to scale to go across the face of it if you lined them up. But guys, right now what we're dealing with mainly, before the impact of that X-flare coming in, is this high solar wind speed. And if you're susceptible to that, then you can feel it, give you headaches, dizziness, the whole 9 yards. But we are dealing with a sun that is making some rapid changes. And we don't know at what point that fourth angel pours that vial out upon the sun. It becomes very active and scorches men. Yet remember, they failed to repent. And the fourth angel, by the way, his M.O., he's the angel of repentance. We're watching it. You watch it. It's a heads up. Be safe.